Good morning, eighth grade. I hope we're having a great start to our morning. This week, we're going to be talking all about squares and square roots because those are vitally important with our exponents, and then they will be important when we briefly talk about scientific notation in the future. So, without further ado, let's get to the video. This week, we're going to be talking about squares and square roots. Now, I know a lot of you are probably thinking, how did we get here? What is a square in terms of numbers, and what are square roots? So I figured I'd actually show you where they came from. So in this example, I have a square here. And what we can do is we are trying to figure out the area. Well, I know a lot of you know that we could just do length times width, or side squared. In this case, we do the same thing. So I can just do, if it's a square, I know it's 3 and 3, for example. 3 times 3, my area is going to be 9, okay? So when I square something or make it a square, so I have a side length and I square it, as in one side and then another side, turning it into a square, I get 9. But if I square root, as in I try to figure out what one of the side lengths of my square is, I go the opposite way. So essentially all I'm thinking about is squares, okay? I'm thinking about that the whole time. So let's try to put some of this into our example. Determine the positive square root of 81 if it exists. So I'm trying to think, I have a square that has an area of 81. And I'm trying to think, what could my side lengths possibly be? And this is when I start to think, okay, I have 7 times 7 is 49. 8 times 8 is 64. Well, 9 times 9 is in fact 81. So I know that my side lengths are going to be 9. So the positive square root of 81 is going to be 9. Same thing with 225. I start to think about what it could be. So 10 times 10 is 100. 11 times 11 is 121. 12 times 12 is 124. 13 times 13 is 169. 14 times 14 is 196. And 15 times 15 is in fact 225. So I know my side lengths are going to be 15. So the square root of 225 equals 15. Number 3, determine the positive square root of negative 36. Well, I need to think here. Is there any way that I can have an area be negative? No, there's not. So in fact, since it's asking me for a positive square root, there isn't going to be one. Why? Because I can't multiply two positive numbers and get a negative answer. All right, determine the positive square root of 49. I'm trying to think, what numbers can I multiply? I know that 5 times 5 is 25, so that's not going to get me my right area. 30 or 6 times 6 is going to be 36. That won't be right, but 7 times 7 will be right. So I know the square root of 49 is going to equal 7. That also brings up the point that there's going to be some square roots that probably won't fall right on a number. So when I think about this, I know that the square root of 1 is 1. And I know the square root, whoops, don't want to flip that. I know that the square root of 4 is 2. And the square root of 9 is 3. And the square root of 16 is 4. But that probably also means that the square root of 8 is going to fall somewhere in between 2 and 3. Probably closer towards this way. Same thing with like the square root of 6. It's probably going to fall in between here somewhere. So it's totally okay if it falls in between. but we just have to try to approximate, and we can do that with our calculators as well. We have to try to approximate and recognize that sometimes our square roots aren't going to fall into a perfect number. In fact, when it falls onto a whole number, it is what is called a perfect square. So, let's think about this. Determine the positive square root of the number given. If the number is not a perfect square, approximate which whole number the square root would be closest to, and then guess and check to give an appropriate or approximate answer to one or two of the decimal places. Well, I already know that the two numbers that can multiply by themselves and get to 49 is 7. The square root of 49 is 7. The square root of 62, however, let's see. I'm trying to think about whole numbers that I can multiply by themselves to get to that number. Well, I know 5 times 5 is 25, not close enough. 6 times 6 is 36, not close enough. 7 times 7 is 49, not close enough. 8 times 8 is 64, so it's slightly over 8. So we know it's close to 8. I'm sorry that it keeps flipping like that. So it's close to 8, and now this is just when we start checking numbers. So I'm going to try 7.9 times 7.9, and that's like 62.1. So let's try 7.8 times 7.8. Well, that's 60. So it's in between 7.8 and 7.9. Square root of 122. Well, I know that 12 times 12 gives me 144. Let's see, and 11 times 11, whoops, gives me 121. So I know that it's in between. It's probably closer to 11. So this is when we just start trying some decimals. 11.1 times 11.1 is 123. So it's really between 11 and 11.1. Let's see, the square root of 400. So let's see, what two numbers can I multiply to get to that? So I know 10 times 10 is 100. So I'm trying to think 20 times 20. Well, 20 times 20 actually does equal 400. So 20. And I don't really care about number 9. So that brings us to our first summary. A positive number whose square is equal to a positive number b is denoted by the symbol square root of b. The symbol square root of b automatically denotes a positive number. For example, square root of 4 is always 2, not negative 2. The number square root of b is called a positive square root of b. The square root of a perfect square of a whole number is that whole number. However, there are many whole numbers that are not perfect squares. Okay, continuing on. So, let's continue trying a couple more examples. Now we're moving into taking squares or square roots for our final answer. We're using them to solve equations. So I have x squared equals 169. So the first thing that I need to do in order to solve this equation is I need to take the square root on both sides. Take the square root. So solve the equation and check your answer. So I have x squared equals 169. That's an awful looking 69. 169. And I need to square root both sides. Now the square root of x squared is just x. And I'm trying to think, what two numbers or what number can I multiply by itself to get to 169? Well, in this case, that's going to be 13. Okay. A square-shaped park has an area of 324 yards squared. What are the dimensions of the park? Write and solve an equation. So I know I'm even going to draw a little shape right here. So I know that inside is 324, and I'm trying to figure out x, the dimensions. So I know that x squared is going to equal 324. So now in order to find out what x is, I just need to take the square root on both sides. And the square root of 324, let me just double check this, that way I don't tell you the wrong thing. The square root of 324 is 18. So x equals 18. And then finally for number 3, I need to do the same thing, even though it seems like it's flipped. I still have that x squared, and I'm trying to figure out just what x is. So all I have to do is take the square root on both sides. So I have the square root of 625 is, and I'm using a calculator for this because even I don't know these off the top of my head, which is fine. Square root of 625 is in fact 25. And we aren't going to worry about anything with cubes. Let's go on to the next slide. We aren't worrying about anything with cubes, but number 7, find the positive value of x that makes the equation true. So this is where I need to remember my exponent laws one more time, because I remember from my exponent laws that whenever I had x to the negative first power, that's the same thing as 1 over x to the first. That's also the same for just any number with a negative power. So I can rewrite this as x squared equals 1 over 256. Now again, I need to square root in order to just get x. So I square root both sides. When I square root a fraction, it's the same thing as square rooting the numerator and square rooting the denominator. So I'm going to have x equals, well, the square root of 1 is 1, and the square root of 256, let me just double check so I don't tell you the wrong thing, is 16. So this equals 1/16. And we aren't going to worry about cubes. Is 6 a solution to the equation x squared minus 4 equals 5x? The really nice thing about this problem is that they already tell us what they think the answer might be. So we just have to take that answer and substitute it in for our missing variables. So is 6 a solution? I put in 6 wherever I see an x. So I have 6 squared minus 4. Does that equal 5 times 6? Well, 6 squared is 36 minus 4 equals 32. And 5 times 6 equals 30. So they are not the same. And explain why or why not? Well, we just did the work there. And that's essentially the end of that as well. So, our lesson summary. The symbol square root like that is called a radical. An equation that contains that symbol is referred to as a radical equation. So far, we have only worked with square roots. Technically, we would denote a positive square root as a radical with a 2 right there, but it's understood that the symbol radical alone represents a positive square root. And we are not worrying about cube roots, but cube roots essentially work the same. They just find out what number you multiply by itself 3 times to get to that number. The square or cube root of a positive number exists, and there can only be one positive square root or one cube root of that number. So that is our lesson for today. If you have any other questions, feel free to leave a comment in the section below or message me on Schoology. But until next time, I hope that you have a great day.